Okay, it's after lunch. This is the best time slot to have because I know you guys are all tired right now. I'll try to be as entertaining as possible. I'm here to talk about delegates, and the reason I talk about delegates is because it's one of those things that was difficult for me to learn as a developer, but once I finally got it, I'm like, these things are really awesome, they're really useful. So I try to help people get over that hurdle. We're going to be looking at kind of some basics of delegates, but then we're going to ramp up and kind of look at a lot of the features that are out there. And just as a warning for those of you who don't know, delegates are kind of a gateway into functional programming. So if you're afraid of functional programming, you might not want to sit around for this talk. Otherwise, it'll make you excited. So if you're looking for these slides, you can go to my website, jeremybytes.com, and feel free to tweet awesome things about me as I'm doing the talk. If you'd like to tweet not awesome things about me, please come talk to me about it, because I'm always trying to improve. So with that, let's go ahead and get started. Now, the first thing that we have a problem with delegates is kind of understanding exactly what it is. So I start out with a definition that actually comes from the Microsoft documentation. And a delegate is a type that defines a method signature. That takes a little while to wrap your head around, because if you're a C# programmer and you're kind of used to, well, yeah, I understand types. You know, we've got classes, they've got properties, and they've got methods and all these other things. We've got structs, value types. We've got stuff like int and list of t and all that cool stuff. I understand types, but this isn't quite like those types. Instead of this being something that's like holding data and has functionality, all it does is represent the signature of a method. So it's something that we can actually assign to, and later on we can invoke any methods that are hooked up to a delegate. But it's kind of odd. And like I said, it took me a while to wrap my head around that. Now, we might say, well, what do we care about delegates? Well, there's a lot of cool features, and there's a lot of places where we find them already. One cool feature of them is decoupling code, and we're going to be looking at that today. So they actually allow us to kind of easily implement the strategy pattern, which sounds a lot smarter than it really is. What we'll see, it's just like choosing what we want to do later is kind of what that means. It also helps us with because we can use methods as parameters. And like I said, kind of a gateway into the functional programming world. These are what are known as higher order functions, where we actually have methods that take methods as parameters. And it's actually kind of a cool thing. Now, they have a cool capability, which is called multicasting. And I'll show you what that is, because that's really cool. And then also, if you've ever used an event handler, you've already used a delegate without even knowing it, because event handlers are, in fact, just special kinds of delegates. They're delegates that have a few more restrictions on them. And then the most awesome thing in C# is Linc, Language Integrated Query. I love Linc. Linc is amazingly awesome. I also love Lambda Expressions, as you'll see as we go. And the thing is, you know, we've got all this cool stuff that we can look at. But we're not going to look at them in slides, because I'm not a big fan of slides. In fact, that's my last slide. Is that okay with everybody? I love code. I love showing things in code. So we're going to spend the rest of our time in Visual Studio. Now, the first thing I'm going to do is wow you with my amazing UI development skills. Trust me, just hang on to something. Come on, Visual Studio, I know you can do it. I always get concerned when it says writing component cache. It's like, didn't you do that earlier? Come on, you can do it. I'm pretty sure Visual Studio can do this. So in the meantime, I think I have some shadow puppets that I can do. Come on. Okay, I like that much better. So let me run this application before we look at what's inside of it, because again, I want you to be amazed at my UI skills. Now, this is WPF because I love XAML. XAML is an awesome UI development tool. And as you can see on the left-hand side, we have a list of data items. These are person objects, which we'll see in just a bit. And for those of you who are like, yeah, it's been kind of a really long week so far, and I'm kind of tired after lunch. If you want to give up on the delegates talk, I'll give you a little challenge. Figure out what my data set is, but you're not allowed to use any internet-connected device for that. So if you can figure out what my data set is, please come talk to me afterwards, because you're the kind of geek I want to hang out with. But what we're going to do is we're actually going to work with this data by just doing some processing with it, and we'll see how delegates work by doing this. So you can see we've got some radio buttons here that we can pick, and we're going to put some output data in that box on the left-hand side. We also have some actions with some checkboxes. And right now, this process data button doesn't do anything. This is what we're going to fill in. So first of all, let's take a look at our data class, which is called person. And it's an amazingly simple class. It has 4 properties and a toString method. So it's just got the first name, a last name, a start date, and a rating. So that's just the shape of our data. And then I've overridden the default toString so that we can kind of give a nice format if someone just has toString on this. Now what I want to do is I want to be able to output different strings, different ways of outputting this particular class without having to go in and write a whole bunch of different methods inside this class. And so the way I'm going to do that is by using a delegate. Now, a delegate, like I said, is a type that defines a method signature. So what I want, if I wanted to, for example, have something that could do this toString, I could write a method that takes a person object as a parameter and returns a string. That's a pretty simple signature. So I'm going to write a custom delegate for this, just to start out with. So I'm going to say public, we'll make it a public delegate, and it's going to return a string. We'll go ahead and call this person formatter. And it will take a person as a parameter, which we'll just call input. So if you notice here, I just have a method signature. There's no method body. All I'm saying is I'm creating this custom type, and this custom type represents a method that takes a person as a parameter and returns a string. Now you might say, what's the use of this? Well, now I can create a custom toString method really, really easily in my class. So what I'm going to do is just create another toString here. So we'll say public return a string called toString. And this is going to take a person formatter delegate as a variable. So basically what we're going to do is pass a method as a parameter to another method. Now, why do we want to do this? Well, you'll see why we want to do this in just a bit. For now, inside the body of this method, I need to run this method that's hooked up to it, and that's known as invoking the delegate. So I can say formatter.invoke, and then if you notice down here, when the parameter that the invoke wants is a person object. And that makes sense, because again, we need a person as a parameter, and we're going to return a string here. Now, since we're inside a person class, I'm just going to use this as the parameter. So you're going to use whatever object that we're currently in. And then again, this does return a string. So that means that we can just return the output of this for our toString method. And so basically what we're going to do is run the delegate and return whatever string that delegate method gives us back. Why would we want to do that? I keep asking that question. Well, let's do something with it so that we can see why. Now for this, I'm going to flip to the code behind of our form. Just to keep things simple, I just have everything in the code behind so that we can focus on delegates and not necessarily, gigantic, cool architectures for complex applications. And you can see I have this process data button _click event handler here, and right now it's just clearing that output list box. So what I want to do is I want to use that toString method. But in order to use that toString method, I'm going to need something that matches that delegate. Well, first let me go ahead and put in a for each loop here. So I'm going to loop through each person in our list box. So we've got the person list box.items. And then I have this add to list method, which we can see down at the bottom, which will just add items to our output list. And this wants a string. So I could say person.toString, and that would just give us the default toString method on the object. But we have an overload that says, hey, we can pass in a person formatter variable here. Okay, how do we pass in a person formatter? All we need to do is create a method that matches that method signature. So up here, I'm just going to create a private method that returns a string. So again, it has to return a string, take a person as a parameter. I'm going to call this output last name. It's going to take a person as a parameter, input. And then we're just going to return input dot last name. Are you guys horribly impressed with my coding skills yet? Trust me, it does get better, I hope. So now that I have this, I can actually pass this method to my toString method that I have down here. So I'm going to loop through all the items. It's going to call the toString method, passing in this other method that says, here's what you want to do with this. And if I run this right now and click our process data button, you can see we have the output that's showing that. Now that's not real impressive because this is kind of hard-coded at compile time. And if you notice, I have some radio buttons there, and I'd really like to hook those up so I can change behavior at runtime. So let's go ahead and head that direction. So what I'm going to do is create a variable. Actually, we'll go ahead and put this at the top, which is of type person formatter. So again, that's our delegate type. And I'm going to just call this variable formatter. So what this is now a variable that I can assign methods to as long as they match our delegate signature. So again, take a person as a parameter, return a string. So that means down here in my code, rather than using output last name directly, we can say formatter equals output last name. So again, assign it to the method we want to use, and then pass that variable in. Now, this isn't real exciting. All I did was create an intermediate variable. But what we can see is that our code still behaves the same way at this point. But now that I have that intermediate variable, it would be real easy for me to just figure out that I want to assign one of 4, 5, 6, 7 different methods, as many methods as I'd like to it. So in this case, I want to create some methods that we can use. So I'm going to add a new class, and we'll call this formatters. And this will be a public static class. And it will have some public static methods in it. Now, these public static methods will need to match our delegate signature. Again, take a person as a parameter, return a string. So we'll create a public static method that returns a string. I'm just going to call this one default. Pass in a person. And this one, you guys are going to be really impressed with this. This is just going to call the no parameter toString method. Wow. I see a lot of really excited people out there. Yeah, there's at least one. Now, lucky for you, you don't have to watch me type the rest of these. Unless you want to watch me type. Anyone want to watch me type? See, the thing is, if I have to type big blocks of code, I'll start to tell really bad jokes, and you guys really don't want to hear that. So what I've just pasted in is a set of 4 methods that all match our delegate method signature. So we can see they all take a person as a parameter, and they all return a string. But they all do something slightly different. So again, that first one there, we're just going to do the default that's on our person class. The second one here, called last name to upper, that uppercase is the last name. Hopefully that's kind of self-explanatory. First name to lower, we'll go ahead and lowercase the first name. And then I have full name down at the bottom, and this will do last name, comma, first name. And so that's okay for most Western names. For Eastern names, that doesn't work out too well. But I'll leave localization up to you. So now that I have these 4 different methods that match the method signature, I can assign any one of these to my delegate variable that I have. And what that means is I can hook that up to the radio buttons that I have in my UI. And this is where things start to get really cool. So I'm just going to create a little method here, private void called assign delegate. And what we're going to do in here is we're just going to assign one of these values to the formatter variable that we have. Now, again, I won't make you watch me type in all this code, unless you want me to. Anyone? Yeah, I know. And so basically what I'm doing is I'm looking at, okay, apparently I named it something different. Fine. Actually, I like format person better. I'm going the other way. Okay, so what I've done in this assign delegate is based on the various radio buttons we have, so I have a default string button, a last name string button, a first name string button, a full name string button. Based on that, I'm just going to assign one of those formatter methods to my delegate that I have here. You guys following me so far? This is where things now start to change at runtime. Because instead of assigning this format person directly to this output last name method that I have here, I'm going to call assign delegate. And what that will do is that will look at the state of our UI elements and decide which thing we want to do. In fact, we'll go ahead and just get rid of that output last name completely. Now when I run the application, we'll see that our radio buttons actually work. So if we click on the process data button, the default, again, is the default toString that we have on the person class. If I click on the last name, now we get the last name to uppercase. First name is first name to lowercase. And full name is last name, comma, first name. That starts to get really interesting when we think about what's actually happening here. Because if we go back to our code and look at our person class, what this has given me the ability to do is change the behavior of my person class without having to change the person class itself. It's given me an extensibility point. And if you're one of those solid design principles people, this is an example of the open-closed principle. It's open for extension, but closed for modification. So I can change how this class displays itself when I call toString without having to change the class itself. Now, this class is pretty simple, but we could also argue that this is an example of the single responsibility principle as well. Because we could say, okay, what's the responsibility of this class? What is its reason to change? Well, it's not doing much right now, granted, but probably its primary responsibility is holding the data, holding those fields that it has. Its responsibility isn't figuring out what format it should output itself in. That should be somebody else's job. So this gives us a really easy way to do that. And when I first saw this, I'm like, this is really, really cool. Wow. And then I think I mentioned that I might talk about the strategy pattern. This is a very simple implementation of the strategy pattern, too. So if you're one of those people that are looking for those kinds of elements and saying, oh, that's curious, maybe I can use that in the future. Delegates are a really awesome way that we can get there. Now, if you notice, I created a custom delegate. Now, you probably didn't notice that, but my custom delegate is called person formatter. And that's actually a custom type that I created, just like my person class is a custom type that I created. But I don't have to create custom types for delegates, because the .NET framework has these really awesome built-in delegate types called Func and Action. Has anyone seen Func? Well, yeah, I'm sure you have. So Func is awesome, but the first time you see it, you're like, I have no idea what this thing is. So I'm going to go to help, because I read documentation for some reason. I'm just going to type in func of t, and we'll grab this one, func of t result. And all this is, it's a built-in delegate type that uses generics. So if we look at this, we'll see I have func of t result. Now, t is the argument. It's kind of hard to tell, but those are just parentheses. So this targ, that's the parameter that this method takes. And t-result, if we can see, is actually the return type that's coming back from this func. So basically, this can represent any method that takes one parameter and returns a result. That means that I can get rid of my custom delegate type and use this one instead. Now, before I do that, I want to show how related these are. I'm just going to copy this code and paste it right underneath my custom delegate, and then get rid of some of this white space here. and just show how these things line up. Because again, the first time I saw func, I was like, yeah, I'm not exactly sure what this thing is. But it's just a custom delegate, or a built-in delegate, I should say, that has generics. So we can see, instead of having string, we have tResult. So that, again, we can put in whatever type we want there. And then for the parameter, instead of having person, we have t. And so that means that we can pick any type that we want for that. So what that means is instead of creating this custom type, I can use this built-in one, and that's what I'm going to do. I'm just going to delete my custom delegate type. Now you'll notice my toString method is no longer happy, but all I can do is replace this with func of person string. And this has the same method signature. So again, looking at the two generic type parameters that we have there, the first one is the parameter. So again, person is the parameter. The last one is our output. So that's our string coming back from it. Now notice nothing else in this code is complaining. It's like, that's fine. Take a person as a parameter, return a string. I totally understand that. How much code do we need to change on the calling side? Well, it turns out not much. This person formatter field that I have here, he's no longer happy because this custom type doesn't exist. But if I change this to a func of person string, now everybody's happy again. And I don't have to change any of the other code. So I can rebuild, I can rerun the application, and we'll see that it behaves exactly the same way. So there's our last name, or our default, our last name to upper, first name to lower, and the full name. So it still all works exactly the same way. Now, there's a couple things that I like about using func. I mean, there's nothing that stops us from creating custom delegates, but func is built in, so I like to use stuff that's already there. If I don't have to create something, that's better. There's also something that's a little, I don't want to say esoteric, but if you have two custom delegate types, even if they have the same method signatures, you can't directly assign them to each other. You have to do some casting. And Dave Fancher knows how to do that because he was just showing me that. In the case of func, I can assign anything to this that matches this method signature. So again, takes a person as a parameter, returns a string. And that's why all of our stuff still works. Now, from a practical standpoint, as a programmer, I really like this as well, because let me come back down to this toString method. Now, if you remember before, when I did my little pop-up to say, hey, what parameters does this toString method take? Well, before it said, this takes a person formatter. If I don't know what that is, I have to go look it up. I have to say, oh, person formatter, takes a person as a parameter, returns a string. But if I look at it when it's using func, right here it says this is a func of person string. That gives me all the information that I need in order to use this function. Because it's like, okay, I just need a method that takes a person as a parameter and returns a string. So I have all the information here. And I love when code is obvious. I hate code that hides its intention. So I really like this. Now, the cool thing about what's built into the framework is that there's more than just this func of tResult. There's also func of t1, t2, tResult. So this takes two parameters and has a return type. And then it keeps going. In the .NET 3.5 world, we were limited to this right here, which is a func of t1, t2, t3, t4, tResult. So we could have 4 parameters and a return type. Now, these ins and outs that you see here, these technically have to do with covariance and contravariance, which I'm totally not going to talk about today. And that's in the generics world. But I use these as a little clue to say, is this a parameter going in, or is this a return type coming out? So you can look at the signatures and see that. Now, someone decided years ago that 4 parameters might not be enough, so we want to have more. And so in .NET 4.0, we actually got this one. I really love this one. This represents a delegate that takes 16 parameters. Okay, here's a clue. If you have a method that takes 16 parameters, please, please, please ask a friend to look at your code. I would not recommend using this. Now, I was really hoping that in .NET 4.5, I could have one that takes 64 parameters. But apparently someone decided 16 was enough. So anyway, the correct number is I don't know how much. So we don't have to just have one parameter coming in order to use func. We can use it for a variety of different situations. Now, if we look at what we have here, so has anyone figured out my data set yet? Don't shout it out. You'll give it away. I'm going to ask you how many of them you actually know. How many do you know? 2? There's 7 of them out there. Anyone know more than 2? Okay, talk to me afterwards. So we've seen that we can easily swap out things at runtime. We can change the behavior of a class without changing its code. I love that kind of power. Now you might say, are we going to get into trouble, like abusing that power? Well, if we look at the class that we have, there's really not much that we can do with it. Because what we're doing is we're saying, okay, this is going to take a person as a parameter. Technically, whatever we pass in is allowed to modify that object. So it can change the properties of the person class if it really wants to. But if you notice this particular class, all of the members are read-write. So they all have public setters and public getters. So you can change all of those anyway. Now, if you're more concerned about, am I able to change the things that are coming in here, there's ways that you can get around that. So if I were to create, for example, read-only properties, have a constructor to populate those, then I could actually make a copy of the object and make sure that you're not modifying anything directly. But in this case, this will work for what we have. Now, when we look at the invoke here, we are going to add a little bit of exception handling in a bit. But there's a shorter format that we can use for this. Instead of calling invoke, we can just put parentheses directly after the delegate itself, and that will execute the method. Now, there's times you may want to use this and times that you may want to use invoke, and we'll see that in just a bit. And it's more for semantic purposes. But this works exactly the same way. It will still invoke the delegate and run the method that's associated with it. Okay, so let's move on to the other part of the UI that I have here. This is where this is where you have to start thinking. And it's really cool what you have to start thinking about. Because if you notice, I have this action section here, and it's a set of checkboxes. And so if we look at the actions, I have average rating. Okay, so it needs to go through the items in the list and figure out, if you'll notice, there's like 6 out of 10 stars, 8 out of 10 stars. I want to take that rating value and get an average for it, for everything that's in the list. For the earliest start date, I want to go through the list, and you'll notice these all have years associated with them, and I want to pick out the year that is earliest chronologically. For the best commander, I want to go through the items in the list, pick out the one with the highest rating, and display that person's name. And then for first letters, what I want to do is I want to go through the items in the list, pick out the first letter of the last names, and output those to the screen. So if you notice, I want to perform some kind of operation based on the list itself. Now for this, I'm not going to have any return values. Instead, what I'm going to have is methods that just return void, but take a list as a parameter. So let's just see, how would I create a custom delegate for that? Well, again, I could say delegate void. Again, it returns void, and we'll call this person action. And this takes a list of person as a parameter, which we'll call input. So if I wanted to create a custom delegate, this is the signature that I'd want to use. And again, I could take the list, loop through it, output stuff into my UI output box. But instead of doing that, I want to use another built-in delegate type, and that is action of T. Now, func of T and action of T are closely related, as you might guess. Action of T is a built-in delegate that returns void. So rather than returning a value, it performs some type of action. And we can see I've got a parameter here. So returns void takes a generic type as a parameter. So again, we can use this however we'd like. Now, again, in the .NET 3.5 world, we did have up to 4 parameters available. And for you brave souls who are writing really hard to read code, you can have 16 parameters for action as well. And so this is where things start to get interesting, because we're going to have some nested generics. And those kind of frighten me a little bit, especially the first time I saw this. That's why I wrote out this custom delegate to start with. So this is going to be an action. And we're going to go ahead and call this process people. But I do want a parameter for this. Okay. Now, the parameter that's coming in is a list of person. So I want to have an action of list of person. I love nested generics. It's even better when you start using task, because like a task continuation has a parameter, which is a task of action of list of person, the way that I use it. So yeah, nested generics are really cool. So it does take a little while to wrap your head around this, but remember kind of the outer angle brackets that we have there. Just say, okay, these are the parameters inside, and then the list of person just has its own generic type along with it. So let's go ahead and get rid of this custom delegate, because again, we can just use this class level field that we have. And I want to hook up some methods to this as well. Now, before that, I'm going to do a little bit of housekeeping, because this code that I already wrote, I only want this to run if our string expander is open. So if our string expander is expanded, go ahead and run this little block of code that you already ran. And then if our action expander is expanded, we'll go ahead and do something else. And so what I want to do is basically kind of go through the same process that I did with our func. I want to go ahead and create a method that will go ahead and assign whatever we want to our action delegate that we have. So I'll go ahead and create another method here called private void assign action. And I'm going to start out really simply by just assigning to this process people variable that we have. Now, one thing that I love are Lambda expressions. Does anyone here love Lambda expressions? Does anybody here hate Lambda expressions? That few people. Wow. If you hate Lambda expressions, I have a video on my website called Learn to Love Lambdas. And so you should go watch that, like, immediately, because Lambda expressions are awesome. And if you go to my website and follow the links for the materials for this talk, you will find that there. Okay, so I'm just going to use a Lambda expression here to get I'm just going to do the first one, which is the average rating that we have for all of the items that we have in the list. So this is fun. I'm going to say P goes to, oh, did I lose you already? P.average, R goes to R.rating, and then we'll say .toString. And then I want to put this in the output box, so I'm going to wrap this whole thing in an add to list. Wow, okay. When I go Lambda expressions hard. Well, let's see what this does. So let's go ahead and collapse our string handler and expand our action. Now, I'm not hooked up to any checkboxes yet. In fact, I'm not even calling this method yet, am I? Calling this method would probably be make things work a lot better. So go ahead and call the assign action. And then what we'll want to do is also invoke that delegate, right? So we have the person formatter delegate that we want to, or I'm sorry, process person, process people. Man, apparently I didn't get enough lunch. We have our process people delegate that we want to invoke. And again, if we look at the parameter that this wants, it wants a list of person as a parameter. Well, I have a little method that will get me the collection of person objects, so I can say var people equals people, come on, dot get people. And so that give me a list of person objects that I can pass through here. People, there we go. So what I'm doing is I'm calling assign action, and that will assign this add to list, this P goes to add to list, to my process people delegate variable that I have. And then down here, we're going to go ahead and invoke that delegate based on this people collection that we have. Does anyone have any idea what this might do? Nobody at all? This is a quiet room. Don't make me tell jokes. So I click the button, and I get the average rating for my 7 items that I have here with a lot of decimal places. But here's something that's interesting. Because if I click the button again, now I have 2 of them in my list box. I click it again, now I have 3 of them in my list box. Jeremy must not be clearing out the list box very well. He's pretty bad at that. But it turns out, at the top of this method, I am, in fact, clearing the list box. But what I've actually done is I've used multicasting without even pointing to it. Now, you'll notice that in this assign action, where I assign to this process people variable that we have, I used a plus equals instead of an equals. Now, anyone who has hooked up an event handler will recognize that. Because usually if we hook up a button click event handler in code, we say plus equals and we give it our own method. That's so that we can add our own method to the event handler so that it'll get fired when the event is fired. We can do the same thing with any delegate variable. So what's happening is each time I click the button, it's calling assign action, and it's adding a new method to it each time. So the first time I click the button, it adds it and then executes it. The second time I click the button, it adds another one, and so then runs both of those. The third time I click the button, now there's 3 of them in there. So that's what's happening here. I had so much trouble getting my head around that. It's like, wow, that's kind of interesting. Now, there is an easy way around this, because inside our assign action, we can just reset our variable. So we can say process people equals null. And so that will clear it out every time we click the button. So now if we do the same thing, we'll only get it one time. That deserves a little bit of applause. If you have to ask for it, it's not genuine. Okay, I'm going to take pity on you, because I saw some people that didn't really love delegates, or I'm sorry, love Lambda expressions. So I'm going to show you how awesome Lambda expressions are by modifying our assigned delegates that we have here. Now, if you remember this is based on the radio buttons, and right now we're calling these separate methods in this separate class. But what I would rather do is have code that's like really obvious and easy to read. And for that, I'm going to use a Lambda expression. Now, the problem with Lambda expressions is this. Right? The problem is, if you don't understand them, you look at it and you're kind of like, I have a general idea of what that's doing, but I don't know really what it's doing. Well, the Lambda expression here is simply acting as an anonymous method. And if our anonymous method matches the signature of our delegate, we can assign it to that. Now, all I have to do to kind of get to a Lambda expression is to create an anonymous delegate instead of a named delegate. This terminology is really awesome. I love this. So what we have right now inside of our assign delegate method, this formatters.default, formatters.lastname2upper, these are all named delegates. They're delegates with names. Now, the terminology does get confusing because they are also just methods, but the delegate, again, represents a type that represents the method signature, and then we have variables of that type, and then we assign methods to that type, and it makes my head hurt whenever I have to think about that terminology. And I've had discussions with people of like, what's the best way to talk about this stuff? And usually they're like, I have no idea. So what I'm going to do is instead of using these named delegates, I'm going to use an anonymous delegate. So if you notice here, I have my default method from my formatters class. I'm going to highlight the parameters and the method body. And I'm going to copy that code and come back over here, and instead of using this formatters.default directly, I'm going to type in the delegate keyword and then paste. And what I've just done is inlined that code. And this is what's known as an anonymous delegate, which is a delegate without a name. And so I have this anonymous delegate here, and I kind of said that Lambda expressions can be used as anonymous delegates, didn't I? So that means I can turn this into a Lambda expression. Now, if you've never seen an anonymous delegate turned into a Lambda expression, you are going to be amazed. If there's one thing you write down, this is the thing you write down. Okay, so are you ready? I'm going to take the delegate keyword and delete it. And then in between the parameters and the method body, I'm going to add the equals greater than sign. Maybe. I'm going to try to add the equals greater than sign. That's our Lambda operator. That's it. Now that's a Lambda expression. But the thing is, this isn't usually the way we see Lambda expressions. This is way too readable, right? I can see the parameter is of type person, and it's called input. That looks very obviously like a parameter. And I've got my method body in curly braces. Well, the thing about Lambda expressions is they were designed to be very compact. We got Lambda expressions at the same time we got Linc, and that's when we're like, okay, we want these really short statements that we can put as parameters and methods and just have them all in one spot, easy to read without like blowing up the code. So there's a lot of syntactic sugar around Lambda expressions that allow us to shrink this down. The first one is something called parameter type inference. You should remember that, because if you say it while your boss is around, you sound really smart. All parameter type inference means is that if the compiler can figure out the type of this parameter, I don't have to type it in. So I can come up here to this person type that I have listed and delete it. Now, this is still strongly typed. If I put my cursor over input, it still tells me this is a person. How does it know that? Well, because I'm assigning it to our format person variable, and that's a Func-a-person string, so the only thing I'm allowed to assign to this is something that takes one parameter of type person. So the compiler already knows what I'm allowed to assign to this, so I don't have to type in the type. Another thing is that if I only have one parameter, I don't need parentheses around it. Another thing, by convention, is that because we're trying to make things compact, it's very common to use single characters for parameter names in my Lambda expressions. So instead of using input, I might use P. Now, when I'm picking single characters, I try to pick one that reminds me of what it is. Since this is a person object, I'm going to use P, and that's to help my brain. Another thing is, if I only have a single expression that has a return type, that's returning a value, I can get rid of the curly braces and the return word. And that is a complete Lambda expression. And it has the same functionality as my separate method that I was calling formatters.default. Now, I know we've known each other for almost 45 minutes now, but I also know you don't trust me. So what I'm going to do is I'm going to comment out the formatters.default method so that it's no longer available. And I'm going to run the code, and we're going to see that still works. Ooh, yeah. That's pretty cool. Okay, let me do that one more time, a little bit faster with this last name to upper. So again, I'm going to copy the parameters in the method body. We're going to come over here and type in the delegate keyword and paste. And again, now I'm going to delete the delegate keyword and put in the equals greater than sign. I can delete the parameter type. Since I've only got one parameter, I can get rid of these parentheses around it. By convention, single character parameter names, and I can get rid of the curly braces and the return keyword. That doesn't seem quite as difficult as it did before, does it? In fact, once you get used to this, now you can just start typing Lambda expressions directly into this. So this first name to lowercase. Well, I can say P goes to P.firstname.toLower. And down here for full name, I can say P goes to, in this case, I'm going to do some string interpolation. P dot last name, comma, P dot first name, just like that. And again, because I know you don't believe me, I'm going to comment out the entire formatters class. Boop, boop, comment it out, gone. So the only code that I have is the code that I'm seeing right here. And my code behaves exactly the same way as it did before. So again, there's my default toString, last name to uppercase, first name to lowercase, full name. And when I look at this code, everything I need to know about it is on this one screen. And I like that. I don't like to have to go to other places to look for code. Now, obviously, it makes sense to separate things when you've got big chunks, you're trying to make things understandable and readable. But as far as the number of lines of code that I have here, on this screen, I have exactly the same number of lines that I had when I was using the formatters class. But now I see exactly what's going on right here next to my code. And I really love that. So I can see, oh, uses the default toString. Oh, it does last name to uppercase, first name to lowercase. Those were probably obvious based on the names of the methods. But for full name, what does full name mean? Well, here I can see it means last name, comma, space, first name. So I like having that code directly in front of me. And once you see that, again, you kind of get used to it. You work with it for a while. And pretty soon, something like this doesn't look quite so foreign. Now, I do have some other... I want to hook up the checkboxes here. So I'm going to go to my snippets. I'm not going to make you watch me type all of this code, because this is a lot of code. But we can walk through what it's doing. Now, since we have, let me get rid of my, let me get rid of my taskbar, so that'll give me a little bit more space here. Lock the taskbar, automatically hide, there we go. I think I can see the whole thing. Oh, that's close enough. So now I've hooked up things to the checkboxes, so I have the 4 checkboxes. Now, you'll notice here, I don't have if statements that return. Instead, what I'm doing is I'm using that plus equals operator for each of these. So I can assign more than one method to the same delegate variable, and then when we invoke it, all of them are going to run. Just like we saw 3 copies of the same method running, we can have copies of different methods that all run at the same time. Now, this first one, again, we've already seen that, takes the average rating and then outputs it to the list box that we have on the left-hand side of the screen, or right-hand side of the screen, I should say. Now, the second one is getting the earliest start date, so it's using a min, a cool Linc function, on the start date, toString based on short date format. I will apologize for that format before you see it. And I'm adding that to the output list. Now, this third one is actually doing a messagebox.show. So this is where we want to show the name of the highest rater, the highest rated commander that we have on the list. So it's going to do a little bit of Linc, order by descending based on the rating. So the highest one will be at the top. Take the first one, toString that, stick it into a message box. And this last one is actually going to write to the output window of our application. So it's just going to do a console.write, and it's going to take the first character of the last name and then just kind of append those together so that we'll see all 7 of those. Okay, let's see how these work. Because multicasting, man, I love this stuff. Okay, I'm going to do them one at a time because I'm not feeling really brave at the moment. So there's our average rating, 6.4. Okay, so we have some formatting for the decimal places. Earliest start date is 10/17/1975. Now, I apologize because I am American if you haven't figured that out yet. And so we do our dates backwards. So that's actually October 17th. But we can see that in the output window. And if we were to look at the items in our list, it looks like John Koenig was from 1975. And so that's his date up there. And then for the best commander, again, we'll get a pop-up box, which in this case says Dave Lister. And we can see Dave here has a rating of 9 out of 10 stars. And then we have the first letters of the last names. Now, I want you to look way down here in this part of the screen. Because when I choose that one, boop, they output to there. Now, these are kind of arbitrary actions that I'm performing at the moment. But I just want to show, KHCLSMG, that represents the last names, Koenig, Hunt, Crichton, Lister, Sheridan, Montana, Gampu. Okay, so I'm outputting all that. Now, things get interesting when we start doing this together. I'm just going to restart it so the output, so that my console output clears. Because let's see what happens when I start clicking multiple ones. In fact, I'm feeling really brave. I'm going to click all of them. So I'm going to have all 4 of those methods run at the same time. Sort of. It's really easy to think that, oh, I can assign like multiple methods to this delegate, and when I invoke it, they're all going to run, and it's probably doing some magic threading on the background so everything runs at the same time. No, it does not do that. It actually runs the methods in the sequence that they're assigned. So the way that I can tell by looking at this code is, if you notice, I did get my average rating, I got my earliest start date, and then I got my messagebox.show, which is a modal dialog, which means my application stops processing. So if I were to look way down here in the corner, where I expect to find the first letters of the last names, I don't see those yet. And if I click OK, we'll see those pop up. Boop. So there's no magic threading. What's happening is the methods are simply being run in the order that we assign them. And things get kind of interesting in some other scenarios. But before I talk about that, just to show this a little more clearly, this one that's using that message box, I'm going to move that up in this method so it's assigned first. So now if we do that same thing, what we'll see is that the message box pops up, but because it's modal, none of the other methods have run yet. And this is something that's important to keep in mind, because things get interesting once we start talking about what happens if you get an exception in one of these methods. Well, the default behavior is, for example, if the first one gets an exception, the other 3 will not run. That's the default way that it works. Now, there are ways around that. You can handle exceptions kind of not by doing the easy .invoke, but there are ways that you can get into the method list, and you can go through and loop through it and run each individually inside a try-catch block, so that if one of them fails, you can still go ahead and run the other ones. If you want some information on that, again, follow the links that are on my website for this talk, and you'll see some articles that I've written about exception handling using delegates. So that's something to keep in mind. So again, modal, as soon as I click OK, now those other 3 methods run. Now, there is one other scenario we need to think about, because what if none of the checkboxes are checked? Well, I get a null reference exception. Because if you notice, I'm trying to invoke on this process people variable that I have here that is not populated. It's actually null, because I didn't assign anything to it. So this is something else that we need to think about, is how do we handle if someone gives us a null? Now, there's a couple ways of doing this. Let me just show you what Visual Studio does, because the Visual Studio IntelliSense and the pop-up help and the little light bulb thing get so awesome with each iteration of this product. So what I'm going to do is I'm going to use the one that doesn't use invoke, and I'm just going to say if process people is not equal to null, then go ahead and do this. Now, you'll notice that before we look at why it's grayed out, let me just show you that this actually does not throw an exception now. Because if nothing's checked, nothing runs. And again, these still work. But you'll notice Visual Studio has grayed out that if line, and it's given me a little pop-up here that says, hey, I can make this look better. Okay, go ahead. So what it did was it went back to using the explicit invoke, and then it used the cool Elvis operator. So that's our null conditional operator. So with the question mark before the dot, if process people happens to be null, it's not going to process it's not going to run anything else. So if process people is null, it's not going to do anything. If it's not null, it's going to invoke the delegate. So that's cool stuff. And I love how Visual Studio just says, hey, do you want to use this new syntax that you didn't used to have? That's cool. I feel really bad for the ReSharper guys because every time Visual Studio comes out, like half of their product is in it, right? So they have to keep coming up with new stuff. So this is really, really cool stuff that I like. Now, I could, you know what? I'm going to do it. I'm feeling brave. I'm going to code up some more. Because something that I'm sure, you know, as OO developers, you're probably not bothered by this, but I know there's some functional programmers in the room, and they're really bothered with the way that I've been assigning these delegates. I can see the look in their eyes. So again, I kept this code intentionally simple so that we could focus on, okay, how do these delegate variables work? How do we assign stuff? Can we do multicasting and all that? But what I would probably do is instead of having actually this separate class level field, I would make it so that this delegate would actually return, or this method would return the delegate itself. So in this case, let me go ahead and move this guy down so that he's local. And we'll just set him to null to start with. Boop, 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 boop. Come on. And then down at the bottom, we can return. Actually, no, I don't want to do that. What am I thinking? I am overcomplicating things. All I have to do is return the Lambda expression. Because, again, these are the radio buttons. So as soon as it hits one of these if conditionals that matches, it should go ahead and return something appropriate. Now, this is going to still be upset, so I'm going to return null if it gets past all of those. And so instead of having this, so instead of having this intermediate value, I'm just going to return the delegate itself from this method. So just like we can use methods as parameters, we can use methods as return types too. And that's really cool. So down here, I have to get rid of this format person because this doesn't work anymore. But I could actually just put assign delegate right in here. I'm not real happy with the readability for that. So what I would probably do is I call it formatter. And then I would pass this through. Because I don't like nesting things too deeply. But that's more style than anything else. But what's happening now is I'm just kind of passing this delegate, this func of person string, around as a return type, into a parameter and this and that, rather than having, these class level variables which we try to get rid of anyway. And I would do exactly the same thing with the action. So we could do the same thing, return that type. Okay, I'm feeling like I am out of time, so I'm not going to do that one. It would take me 2 minutes, and I have 1 minute. So what we're going to do is just do a quick review of why delegates are awesome. Hopefully, I've convinced you that it's at least something to look in a little further, and hopefully you're a little more comfortable with what they are and how they work. In particular, func and action are amazing. You see them everywhere in Linc. And quite honestly, wherever I see a method that takes a func or an action as a parameter, I treat that as a big flashing sign that says, put your Lambda expression here. So I end up using Lambda expressions quite a bit. And again, I'm using them just as anonymous delegates. It's not that hard. It's really, really cool, and I love it. It was a huge hurdle for me. It took me like 6 months before I really got Lambda expressions. But once I did, I'm like, oh, that's awesome. How do I help other people get that too? So hopefully I've done that today. If you do have any questions, feel free to talk to me. I'll be wandering around outside. And feel free to shoot me an email if you have something that comes up later, because I found that if you have a question, probably other people do too, and so they turn into great blog articles. With that, thank you very much for coming.